Okay, question 1. Graph these linear relationships on a number plane. Now you can use a table of values with 2 points, say 0 and 1, and find what the y value is, or okay, we have a y-intercept of positive 1, which is just about there. We have a gradient of negative 2 over 1, which negative 2 instead of rise means go down 2, 1, 2, and a run 1. So there's the point. Y equals 4x, we have a y-intercept of 0. We have a gradient of 4 over 1, which means rise 4, and run 1, and join them up. Now the equation of these lines, y equals mx plus b, we have a gradient of positive 1, so y equals mx plus b, so plus 1 at the end. Now our gradient, to get from this point to this point, we fall 1 and run 2, so we get negative a half. I'll just try and clean that up a little bit. So we get negative a half x. Now b, we have a y-intercept of negative 3, and we rise to get to this point 3 and run 1, and 3 over 1 is 3. Now gradient, rise over run. Now the rise is always the y, the second value. So 3 to 18, we rise 15. 4 to 6, we run 6. 4 to 10, sorry, we run 6. 15 over 6 is 2.5. Now, this time we fall. So from 17 to 5 is a fall of 12. From 1 to 5 is a run of 4. Negative 12 over 4 gets you negative 3. Now you can go the other way, so it would be a rise of 12 and a run in the negative direction of 4, which is still negative 3. Okay, the gradient of each. So gradient rise, which is a 2 over run 4. 2 over 4, which is a half. Now b, doesn't matter which points you choose. From 14 to 6 is a fall of 8. From 9 to 11 is 2. Negative 8 over 2 is negative 4. Now 5, the independent variable. Independent is the shoe size. Now to graph this, okay, the shoe size, 2, 3, 4, 5, 6, 7, 8, 9, 12. So that's your S and your L. Now you would start at 0 and probably go up by 1s, but I don't really have the time, so I'm just going to truncate, and we've got 9, 10, 11, 12, and 13. Okay, so 2, which is there, has a size of 9. 5, which is there, has a size of 10. 7 has 10 and 2/3, which is not quite 11. 8 has 11, and 12, which is just there, has 12 and 1/3, which is, now hopefully that's a straight line. can continue it down until it hits the y-intercept somewhere. Okay, what is a gradient? Okay, so we have a run of 1, a rise of 1, sorry, and a run of 3. So the gradient is 1/3. Now what does that actually mean? It means the increase in length for every increase in shoe size. So every one shoe size increase by 1/3 of an inch. Now how long is a shoe size of 0? So on our graph we will get 8 and 1/3. Now you can do that because the gradient is 1/3, so if we know 9, we can go down a third, which will correspond to the 1, and down another third, which corresponds to the 0, which is 8 and 1/3. Now, how's this shown on the graph? It's a vertical intercept. Now the formula, so L equals, or Y equals, the gradient, 1/3 S, plus the y-intercept, which was 8 1/3. What is the length of shoe size? 7.5. So you put 7.5 where the S is, plus 8 1/3, and it will get you 10 5/6 inches. What is the shoe size of length? 13 inches, so it will be 13 equals 1/3 S plus 8 1/3. How do you get rid of plus 8 1/3? You take it away from 13, so you'll get 4 2/3 equals 1/3 S. How do you get rid of 1/3? You divide, so 4 2/3 divided by 1/3, and you're left with S equals 14. Now, the distance travelled by a car is directly proportional. Now remember, directly proportional is y equals kx, or y equals mx. Now, if 900, so in this case, sorry, the distance travelled is proportional to the number of rotations. So 950 equals k, which we don't know yet, times 540. To get k, divide by 540. K will be 1.759. So therefore our formula will be D equals 1.759 R. So 1,000 rotations. Just don't clear your calculator, times 10,000, sorry, gets you 17,593 metres. You want it to nearest kilometre, which is 18 kilometres. Okay, this graph converts Thai baht to Australian dollars. So we need the graphs, just so remember, 800 baht. So first thing we need to do is, okay, if it's 250 to there, there's 5 things, 250 divided by 5, it each goes up by 50. Okay, so 800 is just there, which is just a little bit above the line, so let's say about $31, because now there's 10 there with 5, so each thing is $2, so that's 32 just there, so it's either 30 or 31. So we're going to say 31. Now 2,450, 2,450, which is just there. Which is approximately there, which is basically on the $94 mark. Okay, now we're doing 65 Australian for Thai baht, so 65, which is just about there. So we go across and just there, so we go down and you get 17, right on the line, 1700. $1,700. Now 82 Australian dollars. Which is just there. Okay, that's $100, 100 baht less, so 2,150. Now, calculate the gradient of this line to 2 decimal places. What does this value represent? So that's the Australian dollars per 1 baht. So the gradient, now you can choose any 2 points. You might as well choose 0, 0. And the other one that I'd like to choose probably is that one just there, which is $10.50 on the X and 40 on the Y. So rise over run is 40 compared to 10.50. 40 over 10.50 gets you 0.038 or something like that, so 2 decimal places, 0.04. Okay, copy the and graph the equation y equals x minus 1. So x minus 1, we have a y-intercept, and we have a gradient of 1 over 1. So rise 1, run 1. Okay, use your graph to solve the simultaneous equation. Where does it intercept? X is 2, while y is 1. Just at this point here. That's how you solve simultaneous equations. Okay, Selma is organising an end-of-year outdoor lunch for the staff. The cost of hiring a tent is $133 and $7.50 per guest. So this is the y, that's the y-intercept, and that is your gradient. Now, Selma is charging each $11. So again, that is your gradient for the revenue. Obviously there are your 2 equations, but if they didn't give you those 2, you could still get those from the values given. Okay, graph both. Now, quite difficult to graph, so again, hard to draw it, but for 0, the revenue, if no one comes, the revenue is 0. If 50 people come, because it wants it 0 to 50, the revenue would be it's going to be 550. So 550, so basically our top number is going to be 550, and it's going to be about there. Now, if we put in the cost, $50 in the cost formula, we get 508. So it's 500. So we're going to go down by 50s, or obviously from 0 up by 50. So it's going to be a little bit higher than that. So the revenue will be there. Now, let's cut some of our graphs. So if 0 guests come, our cost is still 133. So if we do 100 and 150, it's probably about there. And that's basically the graph. Now obviously with rulers you can be a lot more specific. Okay, use the graph to find the cost and revenue for 32 guests. Okay, so 32 guests, which obviously is hard to do, would be maybe somewhere like this. And where are those 2 points? Obviously I can't do it on this graph, but you can do it with the formula. So if you put 32 in the cost formula, you'll get 370. If you put it in the revenue, you get 350, because the revenue is lower at that point. Why would it be unwise for someone to run a lunch for 32 guests? She'll get a loss. Now, for what value of n does the revenue from the lunch equal the costs? Okay, so what is that point there? Now, in a graph, it'd be much easier to see, but it's 38. Why is that called a break even? Because the cost equals revenue, and anything more than that gets you profit. So what is the profit for 50 guests? So as we said before, it's 550. The revenue is 550. The cost is 508. So therefore the profit is $42. Okay, 10, the step graph. Alright, so cost for 3 minutes and 10, which is approximately there. Now one thing to make note of, 3.5 is 3 minutes 30 seconds. So that hits this line about there, which is $4.10. 15 seconds, which is there, which is 20 cents. 1 minute 59, which is just short of, which is about there, $2.15. What is the longest call for $2.15? Well, that's the dot there, which is on 2 minutes. For which of the following ranges of calls duration cost $4.10? So $4.10 is that there. So it is over 3 minutes, not including 3 minutes, and up to and including 3.5. By what rate does the call cost increase? So from 20 cents to 85 cents is 65 cents per 30 seconds.